A couple announcements to start. So homework 3 solution, I will post that tonight. There was just one thing I wanted to double check before I posted it. Normally, by the way, you'll get the homework solution posted around the time of the lecture following, so like Monday. Just gives us time to take a look at what you've all done to start working on the problem. So if I post the solution too quickly, sometimes you have valid ways of solving it, and we miss that. And then it's confusing for you, so we kind of want to have that first buffer time to make sure the solution we came up with is consistent or captures the way that you all have done it. So I'll post that tonight, like I said. In terms of homework 4, so homework 4, I think I have my numbering right. Homework 4 is due Friday. We have an exam on Monday, so what I'm going to do is you'll turn in the homework Friday night. Let's say Saturday evening, I will post the solution right away, right? So that's not going to have this period of time where we've looked at what you've done. We'll just post the solution right away so you can use that to study for the exam. So that implies that you are responsible for knowing the homework 4 material for the exam. So yeah, you'll want to make sure you have a good understanding of numerical solution techniques for conduction problems. And I'll talk just in a second about something there. I will be, it turns out, going on this conference, so I'm going to be gone for lectures 10, 11, and 12. I have already pre-recorded them. I plan to do some final editing and post them all Friday, so I'll just post all of them at once. They're all, about the regular lecture time or a little less, so you should be able to get through them. You can watch them as you want before discussion, or you can watch them all at once. I don't really care. But they'll all be on the YouTube channel on Friday. Exam. Okay, so the exam reminders, that's Monday, next Monday. You get 2 letter-sized pieces of paper, front and back, so that's 4 sides total, with anything you want on it. I will be providing you with, I'll be providing you with a table that is basically the resistance formulas, so resistance in a plane wall, resistance, cylindrical coordinates, like the resistance table that you find in the textbook. So just copy that from Nellis and Klein and you'll have that. I will also provide you with solutions to homogeneous differential equations. So there's that table that I think I showed, just part of the table. I'll give you the whole table. It's like, if this is your ODE in temperature, this is your solution that goes with it. So I'll give you that as well. Anything else that you want is your responsibility. Practice exams. I will post practice exams tonight, probably about the same time I post the homework solution. Those will be pulled from actual historical exams, some that I've given, some that I think are representative of what I would give. I would recommend that you sit down and do those, right, without looking at the solution first, then looking at the solution. Those will be representative in terms of the level of difficulty and what you'd be expected to know. I talked with Professor Nellis. He's agreed to help proctor the exam. So with the TAs, they'll be here. Since I'm not going to be here, he'll also be here to answer your questions. I'll share the exam, obviously, with him beforehand. So if you have questions, he should be able to answer most of them, probably better than I could. So, okay, any questions on any of that so far? Yeah?
What are we supposed to know about numerical solutions since we won't have these with us?
Yep, so the question was, what should you know about numerical solutions? That was my last bullet point. So I'll talk about that now. So you are responsible for numerical solutions. You won't be asked to do that in ease because how could I ask you to do that? So what you should be responsible for there is knowing how to derive the node equations. So for example, you might see something like, here's a problem, and it's a 3-node problem. You are responsible for telling me the energy balance equations for node 1 or node 2, right? Or maybe all 3 nodes. So you'd have to go through and figure out, okay, what's my conduction length? What's my losses to the surroundings? What's the areas involved? And then write out the equation. And in fact, if I were to give you some problem like that, I may ask you to, instead of just writing out the equation how you want, group stuff together. So everything that's multiplying T1 for node 1, let's say, put all that together. Everything that's multiplying T2, put all that together. So you would, say hypothetically, be asked to provide the coefficients on temperature, right, for these numerical solutions. Make sense?
Are any of those numerical solutions questions on the practice exam?
I haven't picked the exam yet, but I could try to look for something. Yeah?
Would you be able to include the resistance tables and the differential equation solutions with the practice exams?
Yep, I'll post on Canvas. I think I'll probably have like an exam folder or something, and then I'll put the stuff I'm going to give you. I'll have it printed out, like stapled to the physical copies I give you, but you can at least see what it is.
About the efficiency of like the fit, do we need any of the specific fit equations we should use?
All right, a question about fin efficiency tables. Let's see, did I say I would give you that? I said resistance formula, ODEs.
I actually don't remember you said something.
Maybe that's a hint. I can provide the resistance. If you need the resistance formulas, they will be provided. Okay, so I'll post those as well, just so you can see what it looks like. Maybe I'll have a last minute change of heart, I don't know.